Hello and welcome to the Daily Space for today, July 29th, 2019. I'm your host, Dr. Pamela Gay, and I am here to put science in your brains. Now, continuing our summer saga, today is a slow news day, or at least it was until 10 minutes before we went live with this episode. I'm afraid that wasn't quite long enough for me to put together all the news stories that suddenly filled my inbox. But tomorrow will be a longer episode. So today I'm just going to give you 2 stories, and tomorrow we will have more. So I guess I will let you get back to your crazy Monday a little bit earlier than normal. So our first story of the day is one of the Crab Nebula. This is an object that many of you have probably looked at through your amateur telescopes, and if you're lucky, you've gotten to look at through something even bigger. This is the remnant of a supernova that went off in 1054, was observed by Chinese scientists, recorded, and has been watched off and on ever since. Since the days of early photographic observing, people have been looking at this particular nebula and watching as its cloud of gas and dust and shock waves continues to expand. We can actually see across the decades this object changing, and well, those filaments that define its crabby nature are moving out relative to the background stars. Now, this particular system happens to have in its very heart a neutron star, the leftover remains of the much bigger star that originally, well, lived and breathed and eventually exploded in 1054, or its light got to us in 1054, allowing us to watch over time as this supernova evolves. Now, that remnant, that neutron star in the center, is one that is rotating more than 30 times per second. And as it rotates, we see its very powerful magnetic field beaming high energy particles, low energy particles, and every energy of particle in between at us 30 times a second. Now, this particular system gives off extremely high energy particles, high energy photons. These are some of the highest energies that we've ever seen. Now, just how high these energies can go is something that is still being learned. And part of the reason this is still being learned is detecting high energy particles can be extraordinarily difficult. If you're trying to look at them with an orbiting observatory, well, high energy particles quite often would rather pass through your detector than get detected at all. So we can't always see them from space. Instead, we end up seeing, well, the cascade of particles that these high energy photons generate when they interact with our own atmosphere. These particles are in and of themselves blocked, for which we're grateful, because if they made it all the way to the surface of the planet, they'd be blasting apart our DNA on a regular basis, and that is bad for life. Now, instead, when these particles hit our atmosphere, they have a fairly good probability of colliding with something, and their individual energy, the individual energy of the photons, gets transformed into a shower of a myriad of, well, harmless particles that instead rain down through our atmosphere. And it's these harmless particles that we work to detect. New research conducted using the AS gamma detector in Tibet has detected the highest energy photons ever recorded, photons generated by the Crab Nebula's pulsar. And these photons are 30% more energetic than the previous record holders. The AS gamma facility is organized is administered by China and Japan, and it includes an underground liquid detector. This is similar to the ones that are used to detect neutrinos at a variety of facilities in Canada, Japan, the United States, all around the world. In this case, this particular shrink-off water detector that's buried underground detects the flicker of light that is generated when these harmless particles interact with the liquid inside the detector. Exactly how much light, what kind of light is given off, directly corresponds to what the energy of the originating photon happened to be. Now, it turns out these high energy photons that were hitting the top of our atmosphere are actually 4 times the energy that can be generated in the most powerful accelerators here on Earth, the accelerator at the Large Hadron Collider. And in the grand scheme of things, 4 times isn't all that much. It's a lot. It's not something that we're probably going to achieve anytime in the near future. But there might come a day when we here on Earth can outperform the Crab Nebula in generating high energy photons. And what makes that all the more remarkable is right now the Crab Nebula is the highest energy source of photons in our Milky Way galaxy that we've been able to detect. So humankind may slowly but surely creep up on the capabilities of a neutron star's particle accelerator. And that's kind of cool. Okay, so to switch gears and to go from pretty picture and stellar death to, well, boring picture and stellar birth. This isn't actually a picture, this is a graph. Here we have a story brought to us initially by the TESS mission and followed up with a myriad of ground-based observatories as well as the Spitzer Space Telescope. In this rather confusing plot, we see a nice smooth set of blue points, and those points that are traced by an orange line, those are the variations in brightness of a star that is still in the process of forming. This 45 million year old star, it's pulsating and irregular, as we know all young stars are, while they go through their initial settling in to join the main sequence phase. For stars like our sun, this period in its life is called a TESS Tauri star. This is actually a much brighter star. And in its nice smooth variations, there are 2 different glitches that have orange arrows pointing at it. These glitches in the star, which is named DS Tuk for Tucana, this is actually a binary star, which is where you get the capital A. And that little B next to it, that's because there's a planet. And that planet is passing in front of the star. Now, these 2 glitches that we see point out that there is a star that is 45 million years old, that has a planet that has already finished forming, but is still getting evolved by its interactions with its parent star. Now, I already pointed out this star is kind of interesting, or rather this planet is kind of interesting because it's orbiting a star in a binary system. So what's happening is we have our primary star, there's a planet going around it, and then there's another star further out, and these 2 stars are going around one another. Now, that's cool. Now, since the star is only 45 million years old, it's going through high energy outbursts. It's blasting off, flaring, and all of these different high energy events that this young star is going through are blasting away the atmosphere of this planet. This planet is snuggled and close. It's orbiting every few days, less than a week it takes between orbits. And as we're watching, we're getting to see the processes that cause young planets to lose their primordial atmosphere. The atmosphere we have over our heads right now and all around us, allowing us to breathe, this didn't come with our planet. This was brought to us later. Any initial atmosphere we had was blasted away when our own sun went through its own terrible tantrums of youth. This is one of those rare times where we can actually watch the processes that until now had been theoretical. We had seen stars go through terrible phases in their youth. We knew from our own studies of our solar system that, at least in our solar system, it appeared there'd been a violent early period in the solar system. Now we're getting to see it happen in other solar systems. And it's nice to be able to say for once that this one piece of our understanding of planetary formation, well, it appears to be true. So here's to planetary formation models actually being right for a change. And those two stories pretty much wrap up the news that I had when I started prepping this show this morning. And as I said, a bunch of new news came out just as we were getting ready to go live. So I will bring that all to you tomorrow. But for now, I'm going to look and see what your questions are. And I'm going to encourage you to please type in your questions now if you haven't already. And when you do, please at CosmoQuestX so I can find them. While you're typing those questions in, I'm going to remind you, the Daily Space is brought to you most Mondays through Fridays right here on twitch.tv at 1 p.m. Eastern, 10 a.m. Pacific. That is 6 p.m. London time. If you miss an episode live, well, you can always find us archived over on YouTube. Just search on the hashtag Daily Space. We are a production of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. Your donations are what make this show possible. We are here thanks to the generous contributions of people like you. And I'm not going to lie, the summer months are slim. It's getting hard going. If you have anything to give, it would be greatly appreciated. Your subscriptions, your donations through patreon.com/CosmoQuestX, and your bits are tax deductible where the law allows. Now, if you can't give a monetary gift, we totally understand. There are other ways you can help our show. And one of the best ways you can actually help is to help us do science. Click on over to bennu.cosmoquest.org and help us map out a rocky little annoying asteroid that has more boulders and rocks than any of us expected prior to getting to the asteroid Bennu. We currently have a little spacecraft called OSIRIS-REx in orbit around Bennu, and it would like to dive down and grab a sample of soil and bring it back to the planet Earth. And we need your help so that it can safely do this grab and go theft of soil. It's only from your efforts, marking the locations of rocks and measuring the sizes of boulders, that we're going to find some place big enough and safe enough for us to dive down with our spacecraft. So please, once again, click on over to bennu.cosmoquest.org and help us map out Bennu. Okay, so let me scroll back and see what there is in the chat. Now, I'd like to start out by thanking Dewey Dipley for subbing to us with your Twitch Prime. Thank you so much. This is what keeps our show going. Hello, Guido. Hello, Wicked Wonder. Hello, Ironheart 50. Hello, Kevlar 1066. If you say hello, I may go back and say hello to you. I'm seeing complaints that you're still only hearing me on the left. I'm using Wirecast today. I'm going to fight to fix this. It's a Monday. It's a Monday. Sorry. I will be working to fix it. I'm glad it's not bad in 7.12 surround sound. I don't know why it's heavily left balanced. This is me. So that's the gain knob. That's the gain knob. Did that have any effect whatsoever? No, that did not. I think I just, okay. I I will fight with it. Sorry about that. Yes, Wicked Wonder. Gamma rays would love to alter your DNA, but probably not in ways that would make you Spider-Man. More likely it would just kill you. And I don't encourage that to happen. Yeah, Larry, it is China and Japan working together in Tibet. It's one of those things where you got to wonder how that collaboration got started. And it's kind of awesome that sometimes scientists can see past national boundaries to make research happen. So Astro YYZ is asking, when you talk about the detector, can you please elaborate? Like neutron detectors that have sensors in heavy water for detecting neutrinos. Yes, this is very similar. The article that I read, and it was brief. This show got prepared in the hour before going live. And this is a detector that I really couldn't find details on. I spent 20 minutes trying to find details. I couldn't find those details. So what they referred to it as was a water shrink-off detector. What this tells me is the particles are interacting with water, probably heavy water, but I couldn't find confirmation of that. And during those interactions, a brief flash of light is given off. This is the particle switching energy levels. I don't know if it's by destroying the particle or what. Again, I couldn't find those details. But the shrink-off water detector is surrounded by photo multiplier tubes, which are extraordinarily sensitive light detectors, and they're looking for these emissions of light that indicate that there was some sort of an interaction. I'm sorry that I can't explain more. If anyone can find a link to this detector that actually says anything in detail, it would be greatly appreciated. I suspect that because this is a Japanese, Chinese, and Tibetan collaboration, that what we're suffering from is most of the details just aren't English language. This detector was also built in 2014, and so it hasn't been around very long in the grand scheme of things. Hey, Ed Thompson. So Falco Online says, is this a binary system? Are both stars being born at the same time? And can birthing stars already have planets? So at 45 million years, stars have already begun to have nuclear burning going on if they are large enough. These are larger stars. Larger stars form quickly. They have more mass. Everything accelerates down. So yes, these are full-fledged stars. They're just not very evolved stars. And there's research that shows that planets can form in as little as 300,000 years once the process gets going. So yeah, planets can have formed. Now, they won't be very evolved planets either, so they're still cooling off. Their atmospheres are getting blown away. There's lots of interactions between the star's radiation and the planet. But these are the early days, and the masses are there. The masses just haven't finished figuring out, well, what they're going to look like when they're fully settled in. So Hanny asks, is the planet much closer to its star than Earth, or have the planets in the solar system slowed down since formation? So things that slow down over time are things like the rotation rate of a world that has a moon that is far enough out. So our Earth's moon, as it moves further and further away from the Earth, is slowing down the rotation of the Earth. The Earth used to rotate faster. What doesn't change, unless there is some reason that things migrate, is how long it takes for planets to orbit around a star. There are things that we think cause planets to move in closer to their star, giving them faster orbits over time. But unless there's a crazy resonance, like we think once happened between Saturn and Jupiter, things don't get thrown into larger orbits. So in this case, we're seeing a planet that formed either close in or very quickly got dragged into a closer orbit around its star, and that's where it's going to stay. So yes, we're looking at a planet that is close into its star, probably closer in than Mercury. These details weren't in the press release, but when you see a 6-day period, you're looking at something that's close to its star. So yeah, it's close in and has a fast period. So Falco asks, you said the Crab Nebula is part of our Milky Way galaxy. I thought nebulas were faraway clusters of gas. So nebula come in many different varieties, and they're in many different places. Most nebula that we can see details in, like this one, are actually within our own Milky Way galaxy. So when we talk about planetary nebula that we can see the details of, those are stars like our own sun that have exhaled off their outer atmosphere, and it's a remnant white dwarf that is sitting in the core of that planetary nebula. When we see supernova remnants like this, like the nebula in Cassiopeia, these are supernova that went off historically within our own galaxy. Now, with the biggest telescopes, we can see supernova remnants in other galaxies if they're young. So we can see the supernova remnant 1987A, I think is the number, in, I believe it's the Large Magellanic Cloud. It's in one of the 2 Magellanic Clouds. That's in a nearby galaxy. We can see planetary nebula in nearby galaxies using things like the Hubble Space Telescope. But in general, individual nebulae like this that you can see with your average telescope and you can make out details on using the Hubble or the Very Large Telescope, those are all in our own Milky Way. Now, as we look out, we do see large molecular clouds indicated to exist between the galaxies. They absorb out light, changing how we see the rainbow of photons coming to us from other galaxies. This is what's often referred to as the Lyman alpha forest, as all of these different nebula, which are filled with hydrogen, absorb out light from the Lyman alpha line in excited hydrogen. But one of the confusing factors is once upon a time we didn't know that other galaxies were actually other galaxies. So you can find references to the Andromeda Nebula, the Whirlpool Nebula, and these are actually galaxies of billions of stars orbiting their own supermassive black hole, just as we see in our own Milky Way. So historically, galaxies, planetary nebula, Crab Nebula, like supernova remnants like the Crab Nebula, all these different nebula were all seen as being similar kinds of things, and now we recognize it as the exhaled atmosphere of a sun-like star, the exploded remnants of a supernova. We also see star-forming regions which are filled with gas, like the Orion Nebula. And then galaxies, which are their own thing and can contain all these other kinds of nebulae. It's a little bit confusing because the word nebula got used before we had good telescopes. So Henny asks, do we know about all the supernova in the galaxy or just the ones on our side of it? So for the most part, we only know about supernova in our galaxy that aren't hidden behind dark clouds of dust and gas. So we easily see ones that are above and below the plane of the Milky Way galaxy. So they could be on the other side of the galaxy from us, but they're above or below the plane, so their light isn't blocked. We can see new things going off on the other side of our galaxy if the energy is given off in gamma and X-rays, because that light penetrates through all the gas and dust. So, for instance, there is a magnetar, a star with a very strong magnetic field that rearranged its magnetic field back in the early 2000s, and the blast of gamma rays it gave off when this occurred was easily detected and kind of wrecked the day of many orbiting satellites. Because of those high energy particles, but we can't see historic supernovae that way. We can only see new ones. And we haven't yet, and our galaxy seems to be overdue for a supernova. So here's to hoping that we get one soon and it's on our side of the galaxy so that we can see these beautiful remnants, as well as, well, having some satellites knocked out by the high energy photons. Mythtown, I see you saying I hate you, Bennu. I think a lot of us hate Bennu because, yes, it has so many rocks. But I'd ask all of you to please hate map Bennu with me and with our own Annie Wilson, Binary Ablaze here on Twitch, Zarin over on Discord, so that we can find a good place to try and land and grab soil and go. Bennu is a dust bunny. It's also a rubble pile. It is, honestly, I suspect, literally a rubble pile. Something that got shattered apart and gravitationally came back together. It's a mess. It's just a mess. Go look at it. It's a mess. Thank you for the bits, Ed Thompson. Thank you so much. This is what keeps us going. Yeah, Bennu is like the guest that doesn't know when to leave the party. It's true. It's true. Oh, Planetary Kristen, I'm sad to hear that you're homesick today, especially since it was just your birthday. I'm glad to hear you're going to go map Bennu. Thank you. Thank you for the bits, Keeper of Maps. Thank you so much. I have a dog. He's right beneath the dog cam. Let me see if I can get the dog cam working. It decided it hates me after I moved my computer. So around here we tend to thank people with cuteness, and the cutest thing around is, well, our dogs. So this is what we often do. We show you pictures of our dogs because we can. Let's go to a video capture device. Logitech Brio. Hey Stella, you can come in too. Ooh, it's giving me like this 320 by nothing image. Let's get a bigger one. It's still tiny. There we go. I will have a cute dog for you in just a moment. A very sleepy, cute dog. There he is. 7.1, that makes far more sense, Wicked Wonder. I was trying to figure out what 7.12 was. I know it's louder on the left. I need to figure it out. I'm so sorry I haven't done that yet. Oh, I think the humming in the background is actually my fish tanks. I didn't turn the fish tanks off either today. It's a Monday, people. It's a Monday. So Henny's River asks, how much more powerful would a collider have to be worth building at this point? I think scientists would be happy with every few percent increase in energy output they can get. We're currently struggling because we know there's dark matter out there. We know it's probably particles, but we haven't been able to detect those particles yet. And one of our hopes is that by colliding things together with sufficiently high energies, that energy will transform from being, well, the things that we smash together and their kinetic energy, to instead being new particles that include dark matter particles. There's also a lot of theoretical physicists that are hoping that, well, maybe their theories for supersymmetry, their theories for other models of, well, particle physics will get proven true as we go to higher and higher energies. Exactly what energy the next prediction is at, I don't know, but I know that they are in the process of doing very expensive updates at the Large Hadron Collider. So it's not a lot that they need to turn it up, but they do need to turn it up. So it didn't say if it was that kind of thing referring to the ring imaging shrink-off detector Astro YYZ. It just, in the article, said a water shrink-off detector. It's frustrating. Yes, we are just going to keep going until we're done. The team wishes that they had the data already, but we're going to keep going till we're done. Keep going with Bennu. Keep going. Let's see. I'm looking for more questions. Ed Thomas is like, this is Bennu. Yes, it's a mad, mad world. It's literally a mad, mad world. So Astro YYZ asks, would OSIRIS-REx be collecting a sample in the same way as Hayabusa? It's similar. The way that they're grabbing the samples with OSIRIS-REx, in my mind, is more like an angry vacuum cleaner, whereas with Hayabusa, they're going in and firing basically a bullet at the surface and grabbing the stuff that ricochets off the surface from the bullet. So they have two different styles of getting stuff off the surface. One is more violent than the other. Thank you for the bits, Trekker Kev. Thank you. You're a good human. Thank you, Wayne Johnson, for the bits. You too are a good human. I love the two-armed wave open cage 5. Thank you for all the bits. Oh, we lost Eddie. Eddie, where are you going? He's checking. He heard the word bits and he was looking for Cheerios. I need to go buy more Cheerios. So Keeper's saying your fish are allowed to have oxygen. So the noise is actually because the water level has dipped enough in the tanks that the filter is a bit of a waterfall. So those can get turned off for a little while. Their filters can get turned off. I just didn't. Better, I should just give them more water. Yeah, Hayabusa is a shrapnel collector and Osiris is more like a vacuum. That is an accurate way of putting it. Okay, so that seems to bring us to the end of the questions. Yes, Eddie came back. It's Keeper of Maps. They are like half a gallon down in many, many gallon tanks. They're fine. Anyways, come here, Eddie. Come say hi. Come on up. So here is Eddie not really wanting to stand up. Yeah, puppers are the best. They are absolutely the best. So I'm going to go fix myself some lunch. I will then be around all afternoon. And I'm going to be working on catching up on all the madness. So I'll see you all on the other side. I still don't have the credits working. These are on the list of things I need to figure out today. So in lieu of being able to roll the credits, I am instead going to read them. So once more, thank you to Wayne Johnson, to Trekker Kev, to Keeper of Maps, to Ed Thompson, to Astro YYZ. Oh, that was for yesterday. To all of you for the bits that you've given us. Thank you to Dwayne Dipley for the sub. And to all my mods, you are fabulous and help us keep this community the safe and healthy place that it is. And to all of you out there in the audience, thank you for being here. And thank you for being interested in science. Wherever you are in the world, have a fabulous morning, evening, or afternoon. And remember, get outside and look up. Bye-bye.